For decades, highways were seen as passive infrastructure. They carried traffic. They consumed resources. And once built, they demanded constant energy just to stay alive, lighting, monitoring, maintenance. Then Africa did something no one expected. It built a highway that doesn't just use energy, it produces it. At first, the announcement barely made a ripple outside engineering circles. A pilot project. A regional innovation. Easy to overlook. But those who paid attention noticed something unusual. This highway wasn't connected to massive power lines. It wasn't dependent on fuel-fed generators. And yet, it powered its own lighting, monitoring systems, and smart infrastructure continuously. The secret wasn't a single invention. It was a system. Engineers approached the road not as concrete and asphalt, but as a living energy surface. Solar-integrated materials embedded beneath transparent road layers. Kinetic systems capturing vibration and pressure from passing vehicles. Thermal harvesting mechanisms converting heat absorbed during the day into usable power at night. What made this highway truly revolutionary wasn't just the technology itself. It was where and why it was built. Africa didn't design this system to showcase futuristic ambition. It designed it out of necessity. In regions where grid access is unreliable or prohibitively expensive, infrastructure has to be resilient, independent, and efficient from day one. So engineers flipped the problem. Instead of asking, how do we supply energy to the highway? They asked, how can the highway supply energy to itself? Every passing vehicle became a contributor. Every ray of sunlight became an asset. Every degree of heat absorbed by the road surface was no longer wasted. It was captured, stored, and redistributed. Smart sensors embedded along the route monitored traffic flow, structural health, and energy output in real time. At night, the road illuminated itself, lane markings glowing softly, signage powered without a single external cable. Even emergency systems operated independently, unaffected by outages beyond the highway's borders. What surprised observers most was the stability. This wasn't a flashy demonstration that worked only under perfect conditions. It functioned during peak traffic, during heat waves, during storms. The system adapted, balancing inputs and storage automatically, proving that self-powered infrastructure could be both intelligent and dependable. And once data started coming in, the implications became impossible to ignore. If one highway could power itself, what about entire road networks? What about rail lines, bridges, or border corridors? What about exporting excess energy to nearby communities? Suddenly, infrastructure wasn't just a cost, it was a producer. Urban planners took notice. Environmental analysts ran projections. Economists recalculated long-term maintenance models. The idea of infrastructure as a passive expense was quietly being replaced by something far more disruptive: infrastructure as an energy-generating ecosystem. As the project gained attention, international delegations began arriving quietly. Not for ceremonies. Not for headlines. For data. Engineers from Europe examined the materials. Asian infrastructure planners studied the energy curves. Sustainability experts analyzed life cycle costs and carbon impact. What they found was something many didn't expect. The system wasn't experimental anymore. It was economically rational. Traditional highways drain budgets year after year. Lighting, monitoring, repairs, energy supply, costs that never truly end. But this highway offset its own operational expenses. In some periods, it even produced surplus energy. That changed everything. Because when infrastructure starts paying for itself, timelines shrink. Projects that once took decades of planning suddenly become feasible. Regions previously labeled too expensive to develop move into the realm of possibility. And Africa understood this immediately. This wasn't about copying models from elsewhere. It was about redefining them. Instead of importing energy to infrastructure, energy was embedded directly into the structure. Maintenance teams weren't just fixing roads anymore. They were managing energy systems. Transport corridors became smart assets, not static surfaces. What followed was a shift in mindset. Local universities updated engineering curricula. Startups emerged around smart materials and road-embedded energy tech. Governments began drafting policies that treated infrastructure as both transportation and power generation. And perhaps most importantly, communities surrounding the highway started benefiting directly. Street lighting in nearby towns stabilized. Charging stations appeared without new grid connections. Emergency response times improved because power was always available. The highway didn't just move vehicles, it powered progress. And blueprints, once proven, tend to travel fast. Soon, variations of the concept began appearing on drawing boards across the continent. Different climates required different balances: more solar in arid regions, more kinetic harvesting in dense urban corridors, more thermal capture in extreme heat zones. The idea stayed the same, but the execution adapted intelligently to local conditions. That adaptability became one of the highway's greatest strengths. Unlike traditional megaprojects that force uniform solutions, this system was modular. Sections could be upgraded independently. New energy harvesting layers could be added without shutting down traffic. Software updates improved efficiency without touching the concrete. The road evolved over time, learning from its own usage. And that evolution revealed something deeper. For decades, Africa had been framed as a place waiting for infrastructure. This highway reversed that narrative. It showed a continent designing infrastructure for the future, not the past, leapfrogging old models rather than inheriting their limitations. Global media began to shift its tone. What started as curiosity became analysis. What was once labeled experimental was now described as inevitable. The question was no longer whether self-powered highways worked, but who would adopt them next. Behind the scenes, negotiations began. Technology licensing, joint research agreements, quiet partnerships between African engineers and global firms eager not to be left behind. Yet the most important impact wasn't happening in boardrooms. It was happening on the road itself. Drivers noticed fewer outages. Maintenance crews relied on real-time diagnostics instead of guesswork. Local businesses expanded operating hours because lighting and connectivity were stable. The highway had become something rare in modern development, a system that improved daily life without demanding constant external support. And as the system matured, something even more unexpected happened. The highway began teaching engineers how it wanted to be used. Data collected from millions of vehicle passes revealed patterns no simulation could predict. Certain stretches generated more kinetic energy at night. Others absorbed and released heat more efficiently, depending on traffic density. The road wasn't just producing power, it was communicating behavior. That feedback loop changed how future infrastructure was designed. Instead of static blueprints, planners started building adaptive models, roads that could be tuned over time, responding to usage, climate shifts, and urban growth. Infrastructure stopped being a finished product and became a living system. This had profound implications. Maintenance was no longer reactive. Sensors predicted wear before cracks appeared. Energy output signaled stress long before failure. Repairs became precise, targeted, and far less costly. The highway wasn't just self-powered, it was self-aware. And once that realization set in, the conversation expanded beyond roads. If highways could produce energy, why not parking lots? If surfaces could harvest power, why not sidewalks, ports, or industrial zones? If movement itself could generate electricity, what other everyday actions were being wasted? Africa's self-powered highway had opened a door that couldn't be closed. What began as a solution to unreliable grids had evolved into a philosophy: design everything to give back more than it takes. Other nations were now watching closely, not out of charity or curiosity, but out of necessity. Energy costs were rising. Infrastructure was aging. Climate pressures were mounting. And here was a model that addressed all three at once. Yet despite the attention, the highway remained remarkably unassuming. And that is where the story truly settles, not with a dramatic announcement, but with a quiet realization. Africa didn't just build a highway that produces its own energy. It redefined what infrastructure is supposed to do. No longer passive, no longer dependent, no longer a drain on the future. This road moves people, generates power, adapts to its environment, and supports the communities around it, all at the same time. It proves that innovation doesn't have to come from abundance. Sometimes it comes from necessity paired with imagination. As the world faces aging infrastructure, rising energy demands, and growing uncertainty, this highway offers something rare, a practical glimpse of a self-sustaining future. Not promised, not hypothetical, already moving forward. Because once infrastructure starts producing more than it consumes, the journey toward energy independence doesn't feel distant anymore.